In this video, I'm going to be going over how to classify matter into the four categories: elements, compounds, homogeneous, and heterogeneous mixtures. All of matter can be broken up into one of these four categories, and this flowchart is mostly meant to help you figure out which of those four categories it falls into. So all of matter is going to be anything that has mass and takes up space, which of course is going to encompass pretty much everything you can encounter. So if you can touch it, if you can pour it, if you can breathe it in, anything tangible, which means you can touch it, is made up of matter. Anything that has mass and takes up space. All of matter then can be broken up into two subcategories: pure substances and mixtures. And we'll talk about pure substances first. A pure substance is something that is only made up of one substance, which is why we call it pure. All pure substances can have a chemical formula written for it that just describes how that substance is made up. A chemical formula would be something like H2O, which is, of course, the chemical formula for water. A molecule of water is made up of two hydrogen atoms that are chemically bonded to an oxygen atom. And this molecule of water, it cannot easily be separated. The only way to break apart that H2O molecule is to do a chemical reaction. It's not something that can be physically separated. All pure substances are going to have a chemical formula that you can write for them, okay? Whether it's an atom or a molecule, you can write a chemical formula. What makes an element different from a compound is that an element is a substance that's only made up of one type of atom. So when you are looking at the chemical formula, you're only going to see one element present. There are 118 elements. They are on the periodic table. So if your substance is one out of those 118, then it's going to fall into this category. So some examples of elements would be like iron. The chemical formula for iron is just Fe. Another example would be carbon, which has the chemical formula C. Those are both considered atoms because if you look at their chemical formula, there's only one thing present. The first one is just Fe. The second one is just C. Elements can, however, be molecules, and an example of this would be oxygen. Oxygen does not like to be by itself as a single atom. It's much more stable in this configuration where there are actually two atoms of oxygen bonded to each other. So that is considered a molecule because there are two atoms of oxygen instead of just one. However, it's still considered an element because there's still only one type present. All right, a compound, on the other hand, this is a substance made up of more than one type of atom chemically bonded together. You can still write chemical formulas for these, but they are going to have more than one element present in them. So obviously H2O, our example from before, that is an example of a compound because it has hydrogen and it has oxygen. Carbon dioxide, CO2, that would be another example. Glucose, C6H12O6, has carbon, hydrogen, and oxygen, so that's three different elements. Anything that has more than one different element present. Sodium chloride is another common example. In sodium chloride, it's just NaCl. There are two elements present. There's sodium and there's chlorine. Okay, so those are elements and compounds, and both of those are types of pure substances because you can write chemical formulas for them. A mixture, on the other hand, this is when you have multiple substances physically combined together. And this is different from a chemical bond because if you can physically separate two substances, that does not require a chemical reaction. So that would be something like using a magnet to pull iron, or it would be boiling away one of the liquids present. Those would be two examples of physically separating a mixture. So if you can physically separate into multiple components, it's going to be a mixture. There are two types of mixtures. The first one is a homogeneous mixture, which is a mixture that is evenly combined. So some examples of homogeneous mixtures would be like wet paint. Paint is made up of a lot of different chemicals, so it would not be possible to write one chemical formula for paint. Paint contains a solvent of some kind, usually. It contains pigments. It sometimes contains other chemicals that change the consistency of the paint, and other things that might affect its sheen or the way it dries. So there are a lot of chemicals in paint. It's more than one thing. However, when you are looking at wet paint, at a can of wet paint, and you're looking inside, you can't see all the different components. It's very evenly combined. It's very well mixed. If I take a sample of paint from one part of the can and another part of the can, it's going to be the same consistency. It's not going to change. Another example of a homogeneous mixture would be salt water. Salt, sodium chloride, dissolves in water very easily. So if I were to make a mixture of salt and water, that would be a homogeneous mixture because the salt would dissolve into the water and it would have just one smooth consistency. However, you can't write a chemical formula for salt water because it's made up of more than one thing. It's made up of water and it's made up of salt. You could write two chemical formulas for the components, but not just one. A heterogeneous mixture, on the other hand, is a mixture that is unevenly combined. So this would be something that has an uneven consistency. So if I were to mix together like sand and iron, it would not be totally evenly combined. So you can look at the mixture and you can see the different components, and it would be heterogeneous for that reason. Both homogeneous and heterogeneous mixtures can be separated. You can separate the different components of paint. You can boil away the water from the salt to separate the salt in the water. And you can use a magnet to separate the iron from the sand. But these are, which is what makes them mixtures instead of pure substances. All right, so hopefully that helps. Let me know if you have any questions.